Welcome to Maths for You channel, a past question on vectors from Oxford and Cambridge past paper. A and B are fixed points in the xy plane. The position vectors of A and B are vector A, vector B respectively. State, with reference to points A and B, the geometrical significance of the quantity modulus vector A minus vector B, the vector half of vector A plus B. Okay, let's start with this one. I put a little sketch xy plane, the marked A, B points, the and origin connected, OA, OB, and AB connected too. From that OAB triangle, just the vector triangle, OA is the position vector of A, which is A. OB, the position vector of B, which is B. A minus B we need to investigate, or we need to start with. A minus B. From that the vector triangle OAB, A minus B is BA. We can work it out just to vector addition. A minus B equal BA. But we want the modulus of A minus B. So modulus of A minus B is a modulus of vector BA. The modulus of vector BA is the BA itself. That is distance between A and B, just a simple distance between A and B. That is the geometrical significance of that A minus modulus A minus B. And then half of A plus B, vector A plus B. It is simply at the midpoint of BA. The connecting AB, the midpoint of BA, is the half of A plus B. We just have a little proof or checking. We just take that triangle OBC, triangle OBC, vector triangle OBC, OC equal B plus BC. OC equal B plus BC. B is the vector OB. So B is B, just B, plus BC is half of A minus B. When you remove the bracket, plus B, so B vector B plus half vector A minus half vector B. So vector B minus half vector B is will be positive half vector B. So half times A plus B. So that's OC vector is the half A plus B. The C is the midpoint of BC. That's a significant. So the half A plus B is the vector of C, vector representation of midpoint of BA. Next, we have given the modulus of P minus half A plus B equal half A minus B. P is a circle, and the P is the point which on the xy plane. So so that is what been given, the condition being given as circle. Let's do a bit more investigation, a bit more proof. Let's take that triangle, vector triangle in a red ink. It's OCP, OCP. There from that triangle, P minus half A plus B, P minus half plus A is CP in that triangle. Modulus of that is CP, of course. So that is left-hand side is CP. We just found a CP from that vector triangle. The right-hand side given half time A minus B. That is, we know half of AB is BC or CA. The distance from B to C or C to A, whatever, whichever one, but B to C we stick to. So CP is BC, that is equal to CA, so that's the distance. So it's a distance. Now we just do that. The P is a point, the XY coordinate will change, and the distance CP is fixed because of equal to BC and CA. Therefore, that distance is fixed, and actually move from the point C. So therefore, C is fixed point, and P moves, and CP is BC, is a fixed distance. Therefore, the locus of P is a circle. That's as simple as that. And the actual reference point is C, the half A plus B. C, the vector representation of C is half A plus B. And the radius is CP or BC or C. That is what is half A minus B, which we proved from the first part. Half A minus B, the modulus of half A minus B vector. So that is the question asked, the position vector of the center of P, the radius of P, which we have done now. It is now given A equal to the column vector 2, minus 1, B is the column vector 4, 5, and P is the column vector x, y. Find a Cartesian equation of P, the circle equation in Cartesian format. Right, A is 2, minus 1, B is 4 or 5, and x, y, P. We have given this condition, the modulus of P minus A plus B, half A plus B, equal half modulus of A minus B. Just before we just use that, let's go into this A plus B, find A plus B. A is given 2 minus 1, and plus B is given 4, 5. So add them, the respective components of that vector, x and y. 2, 4, 6, minus 1, 5 is 4. Then half A plus B, then multiply by half, the numerical multiplication. So 6 divided by 2 is 3, 4 divided by 2 is 4, 4 divided by 2 is 2. Therefore, so right, now we go back to that P minus A plus B. P, we know that position vector P is given vector A, column vector A, the xy, sorry, column vector xy. So that's what P, instead of P, I put xy minus half A plus B, which already proved that 2, 3, 2. So xy minus 3, 2, again, simply the x and y, you can add them and subtract. So x minus 3, y minus 2. So that is left-hand side. Again, that is a vector. So the modulus of that is the modulus of the right-hand side. The right-hand side is a column vector. Modulus of that is simply a square root of x component squared plus y component squared, x minus 3 squared plus y minus 2 squared. But at the same time, that is equal. We know that circle is given, this one, half time A minus B. So keep that, the first part is like that. And A minus B, we just 2 minus 1, minus 4, 5. So subtract 2 minus 4 is minus 2, minus 1 minus the plus 5 is minus 5, is minus 6. And the half time A minus B, half time 2 minus 6. So it just minus 2 divided by 2 is minus 1, minus 6 divided by 2 is minus 3. So that's, we know A minus B is this. So minus 1, minus 3. Simply, we want the modulus, don't we? So the modulus is a column vector, a square root of the x coordinates, x components, minus 1 squared plus y components, minus 3 squared, which is 1 plus 9 root 10. For the left-hand side, we already know this square root of x minus 3. So square root of x minus 3 plus y minus 2 squared. That is equal, of course, the right-hand side, which is root 10. If you could square both sides, x minus 3 squared plus y minus 2 squared equals 10. That is the standard format of a circle in Cartesian format. Thank you. Please subscribe the channel and share the contents. That is very important. Share the contents with your friends and other fellow students. Thank you.